It starts down here by understanding the parts fail, then the machine fails. If I can control my parts environment, minimise their stress right down low, I will create reliability. My parts are going to fail because they are overstressed from distortion or they are fatigued from degradation. So I've got to start controlling degradation in the operating area and in the maintenance area, and distortion when it comes to rebuilding and running it and installing it. And then I'm going to have processes and procedures that involve precision maintenance, precision operation. I've got to control the environment that part is in. If my part is inside of the machine, then the local environment around it, the lubrication, the temperature, the interference fit, the distortion, the overload, I've got to control those, because the part breaks, then the machine fails. So I want to build from here, from this concept of minimising stress in my parts, through a series of activities right up to the actual business system running the company. What quality standards must I have to deliver the precision required to achieve that low stress? What engineering standards give me that? What operating practices give me these controls on distortion and deformation? So these, at this high level here, it's about the business processes and the systems the company uses to create this outcome. So when we analyse a company's assets, we keep pushing up our understanding from what fails it, what controls it, what processes must we use, what skills must we use, what engineering and maintenance and operating and financial practices must we adopt, what procedures and practices and documents and processes do we lock into place that then give us the asset management system that produces the results that we are trying to design.
Where would you put ACE3T?
Let me step on to the next step. The accuracy controlled enterprise is the complete system that captures all these.
Okay, so you wouldn't just put it in the top line?
No, the 3 T's you'd actually build at this level here, because what operating target must we run at to ensure that when the plant operates, it's a nice steady flat line. Pressures, flows, gravities, temperatures, whatever the case is.
So all of those are done to that standard ACE3T?
Yeah. Because the 3 T's are the target tolerance test that gives us the narrow distribution that we're looking for. The 3 T's create that very tight distribution. So I've got to have the 3 T's. If I want to have a tight distribution, then I've got to have what is the target that I'm looking for, and how big a boundary will I accept, and then that setting those parameters sets the limit on my process. And of course the final T, the actual test, is to prove I'm within those boundaries. So yeah, we're going to use the 3 T's, or the concept of that, across all the documentation we're going to build. Up here is the documented systems and processes we're going to run the company with to create that reliability that results from low stress operation of our parts. Now tomorrow we'll talk about the 6 steps in the process, because it's all about recognising where the risk is in the machine, where the risk is to the operation from having those risks to the machine, controlling those risks in the operation and in the machine, introducing the right processes to control those risks, monitoring the processes that are actually working, and then ensuring we are always improving, looking to refine this boundary now narrower and narrower and narrower. Because the more precise I am, the more reliability I'll get, the more accuracy I get, and the less breakdowns and less problems result. So yeah, this one's a bigger triangle, and I chose triangles because triangles are the strongest structure in the universe. When you look at the strongest designs, everything's got a triangular shape. It's the strongest structure. So the concept of having a triangle made sense in building robust business processes that are strong, that support the business, that deliver the outcome that you want. So it's the same thing here. Here I've got more definition from those previous slides. So again, part health down to operating practices and maintenance practices, 3 T's and writing the precision requirements that are necessary, choosing the materials of construction. Now we're down to the design phase of that life cycle. Here we're into managing the actual operation with quality practices, supply chain control, lean practices. There are some good lean things that we don't even want to question. Just bring the good practice in. If that lean practice gives us low stress on our parts, go for it. Go for it, because that practice will create reliability. Why wait? And on we go into our business structure. So up here is all the things a business does that are built from the right thinking. Everything snowballs upwards into the processes that lock that result into place. Most companies go the other way. They build the business processes and hope the right results come out, which gets them where they are today, because everything depends on luck then. It's all hoping the right things are going to happen. He was saying, what are the right things to do to create the reliability and put the right things into place across the whole business, across the whole life cycle. So it's about maximising life cycle profit with markedly reduced human error and greatly increased work quality results by delivering the least maintenance commitment while producing world-class reliability that brings operational excellence performance through creating one single holistic business system to address life cycle cost issues and reduce variation and produce the lowest operating equipment risk profile that results in the least operating costs forevermore. So it's a methodology, a step-by-step process across the business requirements that produces maximum profit optimally. And that's what we're trying to build in their plant wellness way. Just one technique everybody uses that company applies in its situation that is right for that business.